Right then, so this lesson we're going to look at hex. This is something that was briefly touched on in the first lesson. It's one that's in the video stream area as a recap lesson, but I don't think you've done it as an actual proper lesson. So we're going to look at it today. Hex is another way of converting numbers so that programmers can use them. It's a much shorter number to write down than binary. There's a brief little table just here that you can see on screen. You can see the denary numbers there, which are the numbers we use every day. You can see what it converts to as hex and what it would look like if you wrote it as 4-digit binary. Okay, so you can clearly see there that the binary numbers match whatever is shown. However, once we get past the character of 9 in hex, that table then converts, and then we've got A, B, C, D, E, and F, and that's as far as the hex table goes, which means that once you've got this far, you then need to use 2 characters to convert a denary number. I'll explain all this in a minute, but all you need to know is that we go from 0 to 9 and then A to F. Okay? So that is the hex table at the top that you can see, just there. All right? You are going to need to know that table off by heart. So there are 16 symbols, but in the table itself, you do not write the 0. You just need to know that 0 can be a character and it just means 0. So can you write down that table? So if you need to, just pause this video for a minute and make a note of that table. All right, pause the video now. So once you've got that table written down, you're going to need to use it at some point today. All right, this is the exact same table just here that you saw on the first slide, so don't need to worry about that just yet. You're going to need to know how to convert between denary and binary, denary and hex, hex and binary. You're going to need to do all those different calculations if you are asked to do it in your GCSE. How do we do it? So let's say you're given the number 155 and you're asked to convert it to hex. All right, so what we do first is we convert it to binary. There you go, that's 155 in binary, just there. So there's my binary table at the top. I've written the binary table, convert it, done. Your next step is you split that binary number. So I've got one binary number there and I've got another binary number there. I rewrite them. So those 4 characters just there have gone down there. Those 4 characters have gone down there. And then all I do is I just write the binary table above it again. So I've got 1, 2, 4, 8, and it would carry on, but I've got no more digits. And then I've got 1, 2, 4, 8, and it would carry on, but I've got no more digits. I've got 2 separate binary numbers. And then what I do is I convert them back. So what would that be? It is the number 9. And what would that be? It is the number 11. Okay, easy as that. Now all I do is I say, well, what is the 9th character in the hex table? It's still the number 9. So I just write 9, just there. Okay, what is the 11th character in the table? B. And as you can see, I've just done it down there. So my actual 155, converted to hex would be 9B. And the reason we're doing this is because it's much smaller to store than a binary number. Okay, instead of using 8 characters to store it, my 8 digits of binary, I'm now only using 9, which makes things much easier to store and much smaller to store. So hex takes up much less space, okay, much easier to remember if you're a programmer, all right, but your computer cannot read it. Your computer will be converting it to binary, which is why we still need to know how to do it ourselves, all right. So an 8-digit number is always represented by 2 characters, okay, and that is a hex character. It's the 7th character and the 7th character. That is not the number 77. So you need to just check the questions as well when you're asked to do those. What about if we did it the other way around? Okay, you're given a hex character of C8, as you can see there. So C is the 12th character up there, and 8 is the 8th character. So your next step is you convert them to binary. So 12 in binary is that, 8 in binary is that. All you do then is push them together. Okay, there's no adding of them, there's no timesing up these, you just push them together. One on one side, one on the other side to make your 8-digit number. Okay. If they ask you to, you could then go to Denary, as it says at the bottom just there, which would give you the number 200. So C8 at the top of your screen, C and 8 converts to 12 and 8, which makes that in binary, stick them together, makes 200. All right. So some examples. What would 101 be in hex? So first step, make it in binary, which makes 0, 1, 1, 0, 0, 1, 0, 1. Okay. We then split it in half, like that. And then what would this be in binary? So I've got 1, 2, 4, 8. 4 and 2 makes 6. And then I've got 1, 2, 4, 8. That one is 5. So my actual answer is I've got the character 6 and the character 5, because that's what they are in the hex table. So that is my hex number. And just to check, there you go. What if we were doing the reverse? What would 8E be in Denary? So I've got 8 is the 8th character. E is the 14th character. So if I do those in binary, 8 is 1, 0, 0, 0. 14 is 1, 1, 1, 0. Squish them together. 1, 0, 0, 0, 1, 1, 1, 0. Makes 142. Okay, so that is just moved there. That is just moved there. Squish them together makes 142. Let's check it. Done. You are going to be given some sheets to do. All right, I'm going to put these with this video in your Teams chat. All right, so watch this video. Have a look in the Teams chat. There will be some files with this as an assignment. I want you to have a go at the sheets. I want you to then either email them back to me, send them direct back to me in Teams as a chat, or submit them via Show My Homework, because it will be going online there too, to remind people that they should be in Teams doing this lesson. All right. If you've got any questions, send me a message in the chat. I'll see what I can do.